is we have the definitions for just all the numbers that you know exist, the real number set. You have irrational, rational, integers, whole, natural. The point is, if I say the word integer, you need to know that's the positive and negative numbers, including 0, no decimals. If I say whole, that means 0, 1, 2, 3, 4, 5, and so on. Rationals are your fractions. Irrationals move on. Become pi, non-repeating, non-terminating decimal. So we look at the first question. How many positive integers less than 50 are multiples of 4, but not multiples of 6? And so you're asked these, these are the type of questions, ACT, and most people in Algebra 2 plan on taking the ACT, I'd say probably either the fall or the spring, yes? Anybody plan on taking it soon? You have 60 problems to do in 60 minutes for the ACT. So how many minutes do you have to do a problem?
1.
No.
Oh.
You have less than 1 minute to do a problem because you have to read the problem. You think you have 1 minute to, you have less than 1 minute to actually do the problem because you have to read it. And these are the type of problems they'll have on there. Not every single time, but you'll have 2 multiple choice like that deal with number sense. Maybe 3 multiple choice that deal with number sense because it's crucial. Now you can do it the long way. And there's nothing wrong with the long way. Except for afterwards, stop, figure out, is there something faster to do? How many positive integers less than 50 are multiples of 4 but not multiples of 6? So what can I do? You guys all want the direct path. Add 5 to both sides, divide by the coefficient. You want that direct path, but you don't need it. Because the first part says they need to be multiples of 4. You have to ask yourself, what are the multiples of 4? What are the multiples of 4? I'll give you a hint. It starts at 4.
8.
Keep going.
12.
12 and then
16.
16.
20.
20.
24.
Yep.
28. 32. 36. 40. 44. And 48.
And you don't go beyond it because you want the ones what?
Less than 50.
Less than 50. Well, that wasn't hard. You know the multiples of 4, don't you? Can't you just list them out? If you want the long way, guys, it's like, how do I do this problem? You want to do it the fast way because you want the least amount of work. So you don't think about doing it the long way and then studying how to figure out how to make it faster. I want numbers that are multiples of 4. There's your multiples of 4. But they can't be multiples of 6. So what do I do? Go through and do what?
Cross out all the ones that are multiples of 6.
Hey, 12 is a multiple of 6. 24 is a multiple of 6. 36 is a multiple of 6. And 48 is a multiple of 6. How many do I have left? 8's the answer. You just want to do the steps. If you don't know the steps, then do the long way. And then afterwards, ask yourself, could I have done it faster? Because what if I said less than 128? Would you want to list all those out? Less than 240. You don't want to. So that means there's a faster way. What is it? What's the first thing we did? What's the first thing you did?
List the multiples of 4.
We listed the multiples of 4. How many did you list? Anybody tell me, how many did you list? How many multiples of 4 did you list? So let's start there. There are 12 numbers that are less than 50. They're multiples of 4. How can you get that number knowing that?
4
How-
times 12.
What?
4 times 12.
Is what?
48.
48. If you take 50 and you divide by 4, it goes before the remainder, it goes in there 12 perfect times, right? And it has a remainder of 2. But we're going to forget about the remainder because it doesn't matter, because the remainder gets us to the next number, doesn't it? What does that mean? When you divide, what are you finding? You're finding how many times that number goes in there. How many times does 4 go into 50, which is how many multiples are there of that number? There are 12 multiples of 4. Now, just think of the multiples of 6 that are multiples of 4. We know 12, 24, 36, 48. I listed out 4 numbers. There were 12. 12 minus 4 is 8, isn't it? So I figure out how many times does the number go in there. That tells me how many multiples. And then I remove, because that's what the next step you did was, we removed all the ones that were multiples of 4. Sorry, multiples of 6. So that's what I did. I looked at what are the multiples of 6, listed them out, just subtracted that many. Somebody in the other class actually found another way to do this problem, and actually pretty fast. Just came up, hey, I tried this and it worked. So you know what I said? Let's do another example. Because just because it works once doesn't mean it works again. It could be a fluke. We did 2 other examples, it worked out perfect. They came up with their own pattern to doing this problem. And that's the point, is get yourselves to think. If you can't, do the long way. That wasn't hard. List and cross out. It's not extremely difficult. What is the 46th digit to the right of the decimal of 1/7? Everybody get their calculators if you have them. 46th digit to the right of 1/7. So, what is 1/7 as a decimal? Just type in 1 divided by 7. Yeah.
You want me to list out like all the
Yeah.
0.14285714229.
0.14285.7.
71429.
Now, I'm going to tell you it's not 29. It's 28. Your calculator, what did it do? It rounded because of that 5. Be aware. So what do you notice, though? What do you think the next number is going to be? 5. Then 7. Then what do you think it's going to be? 1. Then 4. Then 2. Then 8, right? It repeats. That's irrational, by the way. Think of all the decimals. There's a pattern. Could you list off 46 of those numbers and just tell me what the last one is? Yes. But what if I said, what's the 118th digit? What's the 2,345th digit? You don't want to do that. So you have to stop and think first. I can keep writing them all down or realize how many numbers repeat. 6. It repeats every 6 numbers. Now, why is that important? It's because, what's your 6th number here?
7.
Now, I'm not going to rewrite them again because I don't like doing the same thing over and over and over and over again. I find it annoying. I don't like writing 500 numbers down. I'd rather find a shortcut. The difference between you and me is I'm lazier. I memorized everything, so I don't have to do all the work. So you have to learn patterns so you can figure out how not to do work. So if you think about it, what's the 7th digit going to be? If the 6th digit is 7, what's the 7th digit? What's the 7th digit? What digit? 4 is the 8th digit, 9th, 10th, 11th. So 7 is also what digit? It's the 12th digit. 7 is also which one? 18th digit. Which are really, we're just doing what? Looking at multiples of 6. So what is the multiple of 6 that, if I can do ... you can list them all out, or what's the multiple of 6 that's less than 46?
49. Wait.
What is it? I told you it's the answer to everything. It's 42. That means, I could list them all out. I can list them all out. I can list them all out. But that means the for the 42nd digit is 7. Which means, what's the 43rd digit? 1. What's the 44th digit? 2. 45th? What's the 46th digit? 8. That's it. That's it. It's slow. I get it. But you have to learn how to find patterns and look for patterns to get faster. If you've never done it before, it's going to be slow. But you can improve yourself. That's it. I could list them all out and then count, or find the pattern. It works here. Find 2 whole numbers that have a GCF of 15 and an LCM of 225. Now this one's been bothering the other teachers. I love this problem. Because this one, there's really not a shortcut. What does least common GCF mean? It's the largest number they have in common. What does LCM mean? Least common what? Multiples. Funny thing about GCF and LCM is you guys, people who struggle with math, have them flipped. Because you hear the first word. When I say greatest common factor, you guys focus on the word greatest, don't you? Factor is the word you need to focus on, which means break it down. Smaller. When I say least common multiple, guess what word students focus on? Least. So you think small, don't you? But the key word you need to focus on is multiples, which means you do what to the number? Make it bigger. So here's what I'm going to do. I know that GCF is 15. I'm going to list out the multiples of 15. So we have here 15, 30, 45, 60. So this is tedious for you, which is okay. And I just keep adding 15 until I get to 225. And there we are. Those are all the multiples of 15. Because if they have a common factor of 15 in common, that means it has to be a multiple of 15, doesn't it? Now, look at the next part. It has a least common multiple of 225. Now, what that means is the two pairs, if you keep listing out their multiples, guess what number they hit? 225. So what do? Same thing we did first. Is 210. If I list out the multiples of 210, is 225 one of those multiples? No. I mean, 210 times 2 is 420. 195. If I list out the multiples of 195, is that going to give me 225 at all? No. 180? No. 165? No. 150? No, because 150 times 2 is 300. 135 times 2 is 270. Notice, though, it's getting smaller, isn't it? You're approaching what number? 225. So you're starting to see, okay, I'm getting down to my, so logically that tells me somewhere over here has to be it. 120 times 2 is 240. 105 times 2 is 210. If I go one multiple further, I'm beyond 225, aren't I? So that doesn't work. 90. 90, 180, 270, correct? So that can't work. How about take 225, divide by 75. Does it go in there? Yes. So there's your first one. 60 doesn't go in there. How about 45? 225 divided by 45? Yep. It goes in there. So guess what your two numbers are? 75, 45. You know, some of your other class put through a really good idea at the beginning. I kind of had to negate it because you shot it out right away. It's right, but I just got to think. You could have crossed out half your numbers right away. If it's a multiple of a number that ends in 0, what's it going to end in? Couldn't you cross out anything that ended in a 0 right away? Again, that's number sense. And it's just, hey, cross out everything with a 0 first, then cross out. It's like, hey, that works. There's different ways. All right, A is greater than 0, B is less than A. Which of these has to be true? If A is greater than 0, what does that tell you?
It's more than 0.
Which means what type of number? A is what?
Positive.
A is positive. We know that. A is positive. If we were to think about a number line, that means A is somewhere over in this area. This is where A is at. Any number over there, correct? Any number greater than 0. Where's B have to be? It's less than A. Which means, what can B be? It can be negative. What else? It just has to be less than A. Could B be positive? If A is, anybody take honors geometry? If you did honors geometry, I don't know if you guys did it regular geometry. Do you know the word counterexample? Counterexample is just find one thing that makes it false. And that's kind of what you're doing, is you're trying to find one thing that makes it false. Is if A is 17, could B be over here? So B could be positive. It just has to be to the left of A. B could even be 0, couldn't it? It all depends on what A is. So we need to figure out which of these is true. Is B less than 0? So is B 0 or negative? Always. What did we say? No. Because it just has to be smaller than A. If A is 75, B could be 74, couldn't it? So that's not true. If B is B greater than or equal to 0? Well, we know it could be positive or 0, but guess what else we said it could be?
Negative.
We said it could be negative. So that doesn't work. If I square B, will it be 0 or positive? What happens if you square negative? It becomes positive. That's good, right? What happens if I square 0? It becomes equal to 0, so that's good, right? What happens if I square a positive? It's still positive. So what do we know about C so far? So far it's correct, right? We know this one's good. I could try B squared greater than A squared. You just need to find an example where it's not. So Dominic, pick a number for A. What? 8? 8. Pick a number for B. 6. That fits the characteristic, right? 6 squared is 36. 8 squared is 64. So you made this where it looks like these both are true, right? Couldn't B be negative 6? All the way over there? Negative 6 squared is 36. And you got 64. It's not bigger, is it? So it's not this one. I could also choose 8 for A. I can choose negative 750 for B, where therefore B is bigger. The answer is C. It's a hard way to think. But it all stems down to this. And I'll put it on the board. There is this, oh, it's so annoying. You guys remember quadratics? Yes. You learned about the discriminant, and you do more in Algebra 2. It's the chapter that hurts. This is the discriminant. Students bomb this. It's just basic order of operations, but they still bomb it. Here's why. If A is negative, and B is negative, and C is positive. So A is negative, B is negative, C is positive. What type of answer should you have? What's a negative squared? Positive. Negative 4 times a negative times a positive. So if you focus on this, what's a negative times a negative times a positive? A positive. So it's a positive. So your answer should be positive. So when I do quadratic formulas, it's one of those things where I know whether my answer is going to be positive or negative based off the signs of A, B, and C. Because I'm using number sense. I'm thinking first on, well, I know a negative and a positive makes this whole thing a positive, so it's going to be b squared, whatever that is. I'm going to have plus a number. This number, by the way, is always going to be what? If b is positive, what's a positive squared? What's a negative squared? This number is always going to be positive. It's this number sense thinking. On your homework, there's 4 problems. Cross out 21. So really you only have 3 problems dealing with number sense. And during this time, you can ask questions